The countdown. It's the first time we ever did a countdown.
Good to see me.
We've got banners. We've got a countdown. We've got a show. Yash is here. It's Antrea Live. It's me, Vivek, and Yash today, and Srikar. Junjin may explain how, or let me see here. 1 second. Yeah, there we go. Okay, Srikar, and I see Junjin is joining. So, hey, what's up, everybody? Okay, so it's Antrea Live. It's Wednesday, November 3. It's getting cold on the East Coast. What's the weather out there like, Junjin, in California?
It's a last day. Pretty stormy outside.
It's a nice day. Okay.
Yeah.
Srikar, how is your audio working?
Let me check.
Like
Can you hear me?
Sounds good. Yeah, sounds good. Okay. So we had so Yash is here from Staked, and we got a few VMware people here. We've got folks from our NSX, NSBU group who work on Antrea. We got the upstream developers from the Antrea crew here, and of course me from the Kubernetes world. So welcome to Antrea Live, and we've got a lot of stuff today. So let's get into it. So we're going to look at so Vivek is here, and Vivek is a telco guy. So Vivek is going to tell us a little bit about multus. Just a little teaser, because next week we're going to look more into multus and how that plays into different CNIs and stuff. And then we're going to look at how Antrea can do network flow visibility, and then we're going to hack around with Prometheus and look at the OVS metrics. So Vivek, you want to get us started off with just a little teaser for what you're going to show us next week?
Sure. So, hey, everyone. My name is Vivek. I come from VMware, and I work in the telco BU in VMware. And today I just wanted to give a heads up on the use cases for multus in the telco stack as such, and the problems that we are facing, and how we can go about solving them. Right? So to give you a heads up, most of the network functions, especially when we are moving to 5G, the networking needs of such network functions are increasing, and it's also pretty stringent. We are talking about millisecond latencies and throughputs in order of gigabytes, right? So what people have discovered is doing everything and routing everything over the primary CNI interface is not going to work. And there are also use cases in telco world, if you come from a traditional telco world, where they would like to segregate their networks into separate VRFs, and they would like to, generally for security purpose, not allow traffic between different VRFs. So they don't want traffic to flow between the different VRFs unless you go via some dedicated gateways which has stringent security policies. So all these together comes out as requirements where when we have a pod, we might need to have more than one interface presented inside it. Now, the most of the network function vendors as of now are leveraging multus to attach multiple NICs inside these pods, and then they leverage different technologies, like if they want really high throughput, they're trying to go for SRIOV or even SRIOV plus DPDK to even increase the throughput if it's some user plane function. Or for some functions, they're also using something like MAC VLAN bag or IP VLAN bag interfaces, so that they essentially get multiple interfaces inside so that the network functions can consume them.
So do they use this is this for their infrastructure, or is it for stuff that's like on the edge?
It is how the network functions are architected. This generally comes from the VNF world, where there used to be multiple separate VRFs. So we used to have a dedicated network for signaling, because you have to understand holistically how all this ties in is when you create separate VRFs. They're also going to have separate QoS requirements based on what type of traffic they are carrying. So if it's going to be a VRF, which is going to carry user plane data, right, the actual data from the user, that is going to have higher QoS requirements in terms of the bandwidth to be supported. Whereas if it is something which is just carrying signaling messages between different network functions in your 5G network, it might have a different QoS requirement. Whereas if you have a VRF related to your voice call, you really want your latency to be low. So this is how it translates.
What does VRF stand for?
Yeah, I was just about to ask for the layman out here. What's VRF?
VRF is virtual routing function, or it's like a dedicated network, right? VLAN back network. It's a separate VLAN network.
Okay. It's like it's like a VLAN that's not.
So they have separate VLANs for each traffic, right? Based on each the type of data that those networks are carrying, and then they can characterize the QoS for each of those VLANs separately.
Okay, cool. Now, and okay, so we could talk about this for like 10 hours, but I want to give it to Srikar because he joined us last minute today, and we're really excited about some questions that came up in the Antrea community, I think, this week about monitoring network traffic and flow, visibility and stuff. So, Srikar, you want to share your screen and show us the whole visibility flow stuff?
Sure, Jay.
Okay, cool.
I think, but it's short notice, so I did not prepare any demo. But I'll go over the documentation that we have in the Antrea and give an overview of the feature and what are we planning to do.
If this is the main thing, then we can just talk through this diagram right here, right?
Okay. Yeah.
This
is the documentation, and this gives a good high-level architecture.
Yeah, why don't we just take this and put it in my row and go through it?
Yeah, sure.
Or, I mean, you're welcome to share your screen, but I don't think it's necessary. So, cool. Okay, so here you go. So, all right. So, what's the problem that this solves? This whole flow stuff.
Yeah. So, in a Kubernetes cluster, there are multiple nodes, right? And multiple nodes have workloads. Right, and then the workloads have flows in between them, or and then the flows to external network as well.
Okay, so you're saying I've got a node here, and you're saying I've got multiples of these. So I've got a node here, and then I've got another node somewhere else, and this is all one big cluster. Yeah. And so I've got workload pods, and these are talking to each other. So I've got a pod here. And he's talking to this
right.
Okay.
Right. Cool. And sometimes the pods can talk to external network too. Right.
Yeah.
And
so I'm talking to
Yeah. Pods talk to services as well.
I'm going to Domino's.com and I'm ordering a pizza.
Yeah.
Here we go.
Yeah. So anyway,
you like that, Yash? You hungry? Domino's.
I'm always hungry.
There we go. Okay. All right. So I've got external services. I've got internal services. Okay.
Yeah. So the idea is here to collect the information of those flows and keep it somewhere and use it for various applications like visibility applications. Okay. So one major application is just monitoring to see what kind of flows are there and between two pod namespaces. Right, or what kind of flows that are there from a given pod to a different services. So kind of visibility. So the idea is to collect the flow information on each node. And what we do is we run flow exporter as part of Antrea agent.
So you're collecting, when you say collecting the flow information on each node, why do you want to collect it at the node level? Don't you want to collect it at the pod level?
The node has all the flows that are going through all the pods in the node.
Because you have to, because the OVS bridge is on the node.
Right.
So the only way you could do this is because you're using OVS for everything, right? Okay.
Yeah, even for IP tables implementation too, it has to use conntrack, right? So we are basically getting the flows from the conntrack module, not OVS per se.
Oh, you're getting it from conntrack. Okay. So conntrack. So when you say the IP tables implementation, what do you mean? Like there's an IP tables implementation of Antrea?
Like a Kubernetes default CNI, not Antrea. Right?
Okay.
Yeah.
Okay. So like a host port. So I've got a host port and it's going through. Okay. Okay. So if I have a pod and the pod is running, and I'm running Antrea. Okay, so if I've got a pod and it's running here and it's not, and it's on the host network, it's going to go through conntrack, and you're able to collect the conntrack. So do you have to look at both OVS and conntrack for all traffic, or you just look at conntrack?
No, OVS also sends connections to the conntrack to maintain the connection state and everything.
So everything's through conntrack. Okay.
Yeah, the pod network, even the host network, whatever that is there. So it will be available in conntrack module. And we actually, in Antrea, we have a zone, Antrea zone, and all the flows that are related to the pods that Antrea manages, the connections are added onto the Antrea zone in conntrack table. So we go and fetch those connections, which are we convert those connections into flow records, all the information. We have various fields in each flow. Can you go to the document? I can talk about the fields.
Yeah, let's go back. Okay, so we're going back over here. Okay, cool. So let's make this big so we can focus. Okay. No more pizza talk. It's making everybody distracted and everyone's hungry. And okay, let's go. So really quickly before you do that, conntrack is so it's this weird thing that comes up from time to time in upstream, and so it's in the kernel, and I don't understand where it fits into the kernel networking stack. Like in general, with or without any CNI, is it the case that conntrack tracks every single TCP or connection that I make out of a Linux box?
No.
No.
Yeah, sorry. Go ahead. Yeah, you were leading it. So
no. It's
if it's on, I know you can turn it on or off, right?
Yeah, conntrack is mainly for to achieve the firewall rules in iptables or SNAT, NAT address translation. So it has to be you have to program through iptables or OpenFlow. So to go through, it's not every connection that goes through that.
Okay. So for example, just to take an analogy, right? You have a Kubernetes service which has backend pods. And you're trying to connect to that service using the service IP, right? Yeah. And say the pod is in another Kubernetes node. You are talking from node 1, you're trying to connect to that service whose pod is in, say, Kubernetes node 2. Yeah. Now, when you go between these two guys, there is going to be a DNAT because the destination IP, when you send it out, is going to be the Kubernetes service IP, which is a VIP, right? It's a virtual IP. But when it actually goes to that pod, it has to be DNATed, right? Yeah. DNAT it and send it to that pod IP, right? So this DNAT thing is being tracked by conntrack so that when the reverse packet comes, the IP can be changed back so that the connection is established.
Otherwise, we're not going to know. Otherwise, we're going to have no idea because we made a TCP connection to here, and this thing's responding, and when this traffic's coming back,
it doesn't know where to send back. The Linux host doesn't know where to send it, right?
Yeah, because there's multiple places it could send it. So it's like conntrack's job is to track that individual packet in terms of where it's supposed to land when it comes back.
So it actually so whatever case I told is going to be on the second box, because when it sends back, it is going to send with the source IP of the pod, which responded, and when that guy sends it back to the host 1, it is going to put the source IP as the service IP.
Oh, okay. So it's really the arrows I drew. I drew the arrows wrong because the tracking is happening.
That's just an example, right? Whenever there is NATing involved, generally you will also involve conntrack, or whenever there is a external connection which is coming to a pod, we generally involve conntrack because we want to make sure that the external world can talk to these pods, right? Because you have a different CIDR for this internal pods, which is not really known to the external world. So these are all populated by your iptable rules, which your Coop Proxy programs, right? And that is the one which will create these conntracking connection.
Okay.
Whenever you have a new flow which hits that IP table rule, it automatically creates an entry in contract.
Okay, and you're saying the contract, it creates an entry in the contract that lives on the destination.
It depends on where that rule is getting hit, right? So it's either so it depends on the type of flow. It will either be in host 1 or host 2. It really depends on your IP table.
Okay, so it's potentially used on both sides. Okay, cool. All right. So go ahead. All right.
Yeah.
So back to where were we? Where were we,
Yeah.
Srikar? Yeah.
Yeah, these contract. So OVS also uses contract table to achieve this, network policy, firewall, and even natting, right, for various services that we provide in Antrea. So all our connections are present in contract. So we have to as part of flow exporter, we go and poll this contract module periodically with the configured polling interval and get these connections.
Cool.
And these connections have different fields inside them, as I mentioned. And we can, if you go down into the document,
Okay, so here's all the configuration for this. Okay,
Yeah,
so
for flow exporter as part of Antrea agent. Yeah. And can you go down a bit more? And can you zoom in?
Yeah. Yeah. Here we go.
Yeah. So each connection has all these fields.
Okay. Tell me if you want me to go up or down.
Go down.
Go down. These ones.
That's why sharing my screen and doing it myself is better.
Yeah, you can share your screen too, totally, if you want. Yeah.
Okay. Yeah. Let me do that. So it's
okay. So then I bet I could poke around in here and see where this is, right? So. Oh, this works on Windows too. That's nice.
Can you guys see my screen?
I mean, yeah, I see it. You're showing StreamYard though. You're going to want to show you're going to probably want to show your other.
Oh, okay. Let me check. I got only 2 options here.
So while we're free, I had another late question. So what's the difference in information being tracked in IP tables versus contract? I didn't get that part.
IP tables doesn't generally track it, right? It's just a rule to say what you have to do when you match a particular, say, a fightable rule or whatever, right? What you want to do. But if say that involves matting, right? Mat is one of the things that IP tables can do, right? That is one of the tables that it has. So if say matting is involved, or you want to track your flow for any particular reason, IP tables can trigger contract to say, hey, track this new connection. Track this new connection.
Isn't contract a module inside of IP tables? Like there's a thing you can load, like when you do an IP tables thing. Like in Coop Proxy, don't they for some of them load that IP tape, the contract module for some of the commands to trigger it or something?
Yes, internally Coop Proxy, when it programs the IP tables, it does. If you see all the Coop Proxy programs, yes, it will do.
Yeah, like here, Yash. So anytime you see an IP tables rule, so Coop Proxy generates a bunch of these IP tables rules, right? And so like if you IP tables save that.
You can also do conntrack -L. I don't know if you have the command in your box. If you do it, you should see all the connections being tracked.
Yeah. Well, if you run iptables-save on any cluster, on any Kubernetes cluster that in the world that's using IP tables as the proxy, which most of them are, you'll see a lot of these commands. You see this, Yash?
We are not seeing your screen.
Oh, you're not seeing my screen. Let me share my screen
right now.
Srikar's back. I'll show you the IP table stuff later. Srikar's has got his screen working. Okay.
Okay. So yeah, I was talking about in each connection we have various fields that we create. So the fields that we keep track of are the flow start seconds, when the connection has started, and what is the current time when we are tracking the connection flow end seconds, and then the source address, destination address. We have different fields for v4 and v6, source port, destination port, protocol, and
So this is for you're tracking this for every packet?
for every connection.
For every connection from one.
The phi tuple
Okay.
is basically what differentiates connection to connection. Phi tuple is source IP, destination IP, source port, destination port, and protocol.
Okay, cool.
Yeah, and so we have.
When you say connection, it sounds a lot like a packet to me. Like what's the difference?
So the connection will have series of packets, right? So TCP,
Okay.
you can imagine a TCP connection, SYN, SYNAC, and ACK, right? Handshake. So
Okay,
that's
cool.
a single connection.
Got it.
So
That's okay.
UDP also has a connection between source and destination. So yeah,
Okay.
you can imagine that.
Okay.
And in each connection, we also track the reverse statistics, like reverse packet count, reverse byte count, etc. And along with that, we also have a Kubernetes metadata, like the source IP, source pod namespace, source pod name, destination pod namespace, destination pod name, source node name, destination node name, the cluster IP, if it's a pod to service flow, or service name, and then network policy name, policy namespace, rule, and then even the policy type. Also the rule action, such as if it's a reject or a allow or a drop.
How do you, if you have multiple network policies, how do you know what does that field represent? If I've got 100 network policies that are applying to a field.
So for a flow, each flow will go through, each connection will go through a network policy. It will hit a network policy, and we are getting
Is a
the.
network policy an aggregate of all the network policy objects in Kubernetes that correspond to a given connection?
So the right, like network policy is you talk about, like let's say you accept from certain pod label, right, to a service, like, and you will reject all the other connections that are coming from different pod labels, right?
Yeah, but say that I reject from a pod label in a certain namespace.
Right.
Like say I only allow traffic and I have 5 different policies. I have one, like, you know what I mean? Like what that network policy must be.
Each policy has a priority, if I'm not wrong, and you go by the order
right.
of priority. And when one matches, you just use that. You don't.
What is, there will be only one policy which we'll be using. Using in the end, right?
Because so this is a summary of a matching network policy that's allowing the traffic through.
Yeah.
Okay.
Yeah, ultimately.
Allowing or not allowing.
Or denying,
it can also be denied, right? Because you don't want to accept this flow.
Okay. Cool.
Yeah. In Antrea network policy, we also have reject. So
yeah. Cool. Okay.
Yeah. So, and then we also add flow type. Flow type is basically a pod to pod or pod to service or pod to external. So that kind of information. Yeah. So this is these are all the fields that we maintain, and once those fields will be communicated to the connection, or we call them as flow records. Flow records will be communicated to a flow aggregator, which is run inside the cluster as a Kubernetes service with the type deployment. There's only one replica, and so every node has a flow exporter, right? Every every flow exporter inside every node exports these flow records to a flow aggregator. So the flow aggregator is nothing but it collects the flow records and does the correlation, and also the aggregation of statistics
Okay.
if they belong to the same flow. So that is the main functionality of the flow aggregator.
So I see an arrow from flow exporter to K8s info.
Mm-hmm.
What does flow exporter need from K8s other than the initial, feature gate of that it's turned on and some other initial configuration?
So I talked about Kubernetes metadata, right? The source pod namespace, source
Yeah.
pod,
Okay.
and destination pod namespace, even the cluster IP information.
Okay.
No,
So
all
when
this-
it isn't able to fill that information in, it caches it and it goes and talks to the API server and grabs that if needed.
Yes.
Okay,
yes,
cool.
It's basically running.
That way it can export like a human readable thing to the whole. Yeah. Okay.
Yeah, the metadata is very useful for visibility from visibility
Cool.
standpoint.
Yeah.
So that's what happens. Yeah. And currently we support the Porttoport, port to service, and port to external network flows in our flow exporter.
Mhm.
And we support both Kubernetes policy and Antrea network policy, Antrea cluster network policy information inside that. And so going deep into like little if we dive into flow aggregator has, as I mentioned, it has one collector which collects it's like a TCP server which gets all the flow records from different TCP clients,
Yeah.
and then we decode the flow records, and then we send it to a different process called aggregation process, which does the correlation. The interesting thing here is a single connection will have two flow records, one on source node and the other on destination node. So we have to correlate those two flow records and turn them into one flow record. Basically, they belong to a single connection. So if a client pod is on source node and server pod is on destination node, you will see two connections individually on source and destination, right? So the idea here is to correlate that two flow records and convert it into one flow record.
Okay. So something needs to aggregate. So the aggregate needs to talk to all the.
Yeah,
All the
all the
agents?
nodes are sending their flow records, right, inside the
Cool.
cluster to
Oh,
the
this must have-
aggregator.
This must have been some late nights to get this thing working, huh?
Yeah,
Who
it
did
took
all the
some time.
work? Jen, was it you or was it Srikar?
Srikar is our main developer here. Right? That's why we have him talking.
Srikar built the whole thing. Okay.
We have a team as well. Yongming, Yo, and then two other, Yanjun and Lan also joined recently.
All right.
Yeah, it's a teamwork. Yeah.
So okay, good.
And
So
then with Anthony and Jianjun guiding us. Yeah.
So then what'd you do after you were finished? You went to Domino's and celebrated? What did you do to celebrate the rollout of this feature?
Right. So like going into the usability of the feature, right?
Yeah.
So the dashboards. So basically, from the flow aggregator, we aggregate and we correlate the flow records, send it to a flow collector, and then visualize the flows. Right.
Okay.
So we took a out of like shelf solution from Rob Elastiflow. I don't know if you heard of
Elastiflow.
So we got inspired from them and built a very
well, this is kind of gonna. I bet a lot of people will be interested in this. We actually are going to demo Prometheus 2 today, but can you tell us about Elastiflow, and then maybe in a couple of weeks we can go into the next half of this?
Yeah, sure. Yeah, the I can go over quickly about the dashboards and essentially the ELK is Logstash, Elasticsearch, Kibana Stack, right? So we are going to send these flow records there, and we store them in Elasticsearch and Kibana. We build these dashboards and get the flows, right? So
where's Kibana running? Where's who's running Kibana?
We can run inside the cluster.
So what if I don't have Kibana? How does this work without Kibana? What if I don't have ELK? How do I visualize this data? Or I don't?
It's tough to visualize without any UI, right?
Yeah, so it would be like a text file or something?
We are supporting AntCuttle right now.
Okay, so use AntCuttle to grab the. Okay.
Yeah. It's not yet available, but it will probably be available in next release. But
the poor man's solution, the simple man or woman solution would be to use AntCuttle once it's available.
But I feel that it's not very useful because seeing these many flows,
it's just too much data. I got you.
Yeah, too much data. It's very tough. So having a UI is definitely useful from flow monitoring standpoint. Like you can basically see pod to pod flows, and you can filter out like source pod namespace, destination pod namespace, and you can see basically the width, the pipe shows the bandwidth, right? How much
really
data is being So this kind of information, and also we also provide aggregated information, like what is each pod, how much data is sending per second, right, across all the flows. So that sort of information is available, and even the pod to service information is there. Which service is most busy, right? We can get that information. Yeah.
When I see this, people think service mesh, but I think it's really cool. People don't realize how much you can get just from running Antrea as your CNI in terms of monitoring, and then you don't need a service. Who needs a service mesh, right? Like when you've got this, this is the most useful thing that service meshes do, I think, So this is really cool that you could just do this in your CNI for free.
No, I agree. I mean, this is the kind of stuff that companies usually get service meshes involved for. So this is awesome.
I had no idea you could just do this in Antrea.
Yeah, I just want to clarify a little. With service mesh, you can also do level 7 stuff, like level 7 traffic steering, some level 7 policy. For the surface observability of light flows in Antrea is more like level 4 level. So you can see all the TCP, UDP, SCMP, SCTP flows, or level 4 flows. Of course, you have some building monitoring with our dashboard, where you can do some filtering, some time-ranged query, whatever.
Well, it's not layer 7, but it feels like it is, because if you're able to aggregate this with the Kubernetes service that I'm trying to access, that's just layer 7. That, as far as I'm concerned, that's layer 7, right? For pods. Even though it's not really layer 7, I know what name of the service I'm trying to access,
From that front, you're right. Definitely, you can see the traffic between your applications. And in most cases, you know the applications, so you know the traffic belong to which service, right? And we do the correlation in our flow aggregator. So you can see exactly the traffic between which service and which ports, and what light policy are being applied.
Yeah.
Yeah, and in future roadmap, we want to build this service-to-service dependency graph, right? Using various pod-to-service flows. We want to correlate those and build a service-to-service dependency, like how the flows are going from one service to another.
Yeah, because you can, if you get the labels for the pods, and you can essentially, if you can reverse correlate that to the service that those pods correspond to, and then exactly the services are depending on each other.
The only difficult thing there, if a single endpoint is applicable to 2 services, it gets tough. But if it is only associated with one service, it's easy to build a service.
Okay, cool. Cool. Yeah.
Just to add one more thing, since we talk about the deployment of Kibana and ELK Stack, actually it's pretty simple to deploy with Antrea. We have a pre-built image with all the bits there, and we have manifest, so you can just apply our manifest. Maybe popular server config parameters, then you can deploy the whole stack end-to-end. You can see what the dashboard.
Yeah.
Well, should we just? I can deploy it right now. I was about to share my screen anyways.
So you want to talk about some other topics, right? I don't know.
Yeah, like anything else you want to go through before we jump into the demo? We have another 5 minutes if you want to show us anything else, I think, and then I want to do a quick demo of the Prometheus metrics.
Nothing else. As Jianjun mentioned, we have deployment steps. It's very easy to deploy the ELK Stack and check out that. And in future, on top of this, we are planning to build network policy recommendation engine and some performance analytics application from this flow record information. So those applications, visibility applications will be.
Wait, are you using Subversion? I didn't know anybody still used that. What?
Yeah,
who's using Subversion? That's cool.
Yeah.
That's cool. Yeah. You're like very version control inclusive. Giving it Subversion instructions.
I think the whole probably the effort there is to do it in one command, in a simple command.
Okay.
Yeah, that's about it. Yeah.
I don't think Yash has ever used Subversion in his whole life.
Yeah.
He's like 20 years old. I don't think he even knows what it is. Okay.
No,
I know what it is.
We used it in college.
Yeah.
They actually didn't teach us Git in college. They used to. We did everything with Subversion.
Okay, I'm wrong. Yash is okay. Yash is probably okay.
Yeah, so that's it from my side. So there'll be other like policy recommendation engine is what we are, excited about.
Okay.
How it's gonna like using this flow, we can figure out what are the unsecured flows and recommend the policies to customers.
Okay, so future, you got policy recommendation engines, and what else are you working on for this thing?
Another thing is performance analytics. So we have this throughput time series for each flow, and we can see anomalies in the throughput time series, like if suddenly the throughput drops or something, and how many anomalies are we seeing in different flows. Can we get some useful insights from that information? So
this is cool. All right, let's switch over to demo. This is awesome, Srikar. Thank you so much. Vivek and Srikar, you are welcome to stick around and hang out with us for the demo if you want, or not, whatever you want to do. But thank you so much, both of you, for showing up and hanging out with us.
Thanks for the opportunity, Jay.
Yeah. So, all right. So before we jumped into this, this episode, we were going to go over. There's your Coop Proxy I was going to show you, by the way. That's where it generates those iptables commands, Yash.
Gotcha.
So that's where it generates them, and you can see, like, I have this file I keep around iptables save here, and where I just have a bunch of iptables rules that are saved, and you can see like it generates these, and you can run iptables-save on any kind cluster and just see the rules that are there, and you'll see a bunch of stuff like this, where it's loading these are modules. So in iptables, you do this and you do -m, it's loading a specific module that has specific functionality. So it's like loading the conntrack plugin, and then all these are contract specific options, right? So that's how you read a iptables command. And so that's, I think, what they were talking about earlier a little bit. Now, over to the demo. Where's my terminal? Okay, gotta go fast. So I have a cluster. I just made it. So I used the kindlocalupscript that we have here, which uses the Antrea kind installer. So folks you can get this at, I have a repo where I have a thing to install all these here. So you can run the kindlocalupscript from here. I'll put it in the chat for folks if you want to play at home. And you could just download this script. And look, Yash, I don't know, Yash has been doing stuff in here. I don't know what he did. He did something. What did you do? You're helping me out? Look at, I didn't know you did this. Thank you, Yash. Okay, so anyway, so I ran that, and I have a cluster, so Docker PS. I've got a kind cluster. I just made it right before the show. Okay, so it's really easy to see. If you want to learn more about OVS, it's really easy. I was shocked at how easy this was. We have a Prometheus. I didn't even have to ask Jinjun for help. Usually I have to ask him, either him or Antonin for help, but I didn't have to ask this time. So let me see here. Let me remove this. Here we go. Let me delete this because I think I created these already, and I was playing with this earlier. Let me just delete this. So I'm going to delete. I set up a bunch of Prometheus stuff. So they've got the raw YAMLs for running Prometheus. For folks that don't know what Prometheus is, it's a time series database. It's pretty popular nowadays. Most people have used it or have seen a demo of it before. It allows you to sort of, really cheaply and easily publish tons of metrics from a whole bunch of different microservices to a central endpoint where you can aggregate and correlate them and stuff. And so I just went ahead and created these. So I've got a Prometheus deployment here. And the reason I wanted to do this is because I've been trying to learn more about Open vSwitch lately, right? So, okay, I've got a Prometheus deployment running, so I can port forward this pod here, right? So I can port forward this pod to my local 9090, right? Yeah. So I can do that, and then I can jump over here and I can go localhost on 9090. Is it going to work this time, Yash? It did work the first time. Okay. So this is cool because, see, now you can, if you're interested in learning about how OVS works, you can see stuff like you can look in here, and then you could see. Okay, so I've made, obviously we can't see anything yet, but we could see like here's a histogram, right, of all the different tables, right? So there's all these different tables. So each one of these tables corresponds to a different Open vSwitch. So Antrea uses Open vSwitch under the hood. And then Open vSwitch has these different tables. And each of the tables have rules in them. So let me see, OVS tables.
Yeah, I think if you can zoom in a little bit, I think that'd be better.
Okay, cool. Yeah, definitely. Let me do that. And then I'm also going to put this up here. Okay, so here we go. So, okay. So you could see all these different tables, right? And I think 90 is one of the important ones. Let me split screen, right? Let me put some OVS stuff on the right here. So, well, Jinjin, since you're here, why don't you tell us about these tables? What is table 90, for example? And then I'm going to scale up like a core DNS pod or something so we can see what happens to the metrics when we do that.
Sure, I can talk about that.
Yeah, go ahead.
Just give me 1 minute. Probably I need to look at our document too. The table 90 is for ingress net policy rule. It's a table for us to enforce ingress net policy rules.
Okay, cool. So if I scale core DNS down to 1, let's see what happens. So I'm scaling. I have core DNS. Core DNS, as you all know, runs in the pod network, right? So Antrea is going to be writing rules for it. So as soon as I scale it down to 1, right, I've got 11. I've got table 11, and table 11 has gone, or table 42, right? In table 42, the amount of flows in table 42 has gone from 11 to, where are you, table 42? Here you go, to 8. So it went from 11 to 8. So there were 3 flows associated with core DNS. And now so we lost 3 flows. So why did it have 11 flows and then it went down to 8? Well, let's see. What if I go up to 2? Okay, so now I go up to 2, and then I re-execute this query, and it looks like from going to 2, if I go back to table 42, I've got 11, and then if I go, I can actually look at the exact number in here, right? Yeah, I can just isolate this here. So now I've got 8. Well, it should have changed, right? Because I added. There we go. Okay, let's go back to table 42. Okay, it went back up. So by adding 1 pod, I get 3 new flows. Is that because Core DNS has an extra UDP port or something?
I think table 42 actually is for service load balancing. Basically do load balancing by Antrea, we call it Antrea proxy. That one implements service load balancing with OpenFlow. And the 42 actually do the DNet for the service traffic.
Okay.
I think you should add 1 flow for every service endpoint port. So I think Core DNS has 2. At least has 2 ports open. One is for TCP and one is for UDP access.
Yeah, so you got a UDP and you've got a TCP one.
Yep.
Well, it looks like you got 3 metrics. So you've got 3 services here, and that's why it goes from 8 to 11, because you get 3 for every service here. We're getting a new flow. I added 1 pod, right? So watch, if I do this. Fine, so I'm going to add a 3rd one. So I'm going to add a 3rd, and then this is going to go up another 3, right? So right now it's 11, it's going to be 14, right? So we could see OVS responding to that. Okay, so now I go back to 42 here. Okay, 14, see, right? So it's making 1 flow for every one of the these endpoints here, right? So this Kube DNS service has these 3. Has a UDP for DNS, a TCP for DNS, and then a metrics endpoint. I think that makes sense. Does that make sense, Junjun? Pretty much. I think that's pretty good. Okay, cool. So then I can do things like so what are there any other? So I can look at network policies, right? So I can go in here, and these are the total amount of network policies that have been implemented by the Antrea agents. So I could go and I could create a network policy. I think I have an example of this repo where I could do that. So I can cd.cd, and I could kubectl create -f nginx policy.yaml, and then I can, maybe I'll be able to see these. What's going on?
Did you, by any chance, you have links to the documentation for the different tables? And maybe
we should get the tables. Yeah, Junjun, can you paste maybe in the
Actually, I sent to the public chat.
Oh, okay.
Cool.
Maybe I can do it in the private link.
Oh, that's great. Awesome. Hold on. Where is it in the public chat? Where is it? Private. I don't see it.
Did you see it? No.
I don't see it in the public chat.
I already sent it. I don't know what happened.
Let me see. Okay, so let's Antrea flow tables.
It's called. I also sent to the chat. Could you check?
Oh, I just see it now. I see it in the private chat.
Oh, got it. Okay, cool. Nice. Okay, here we go. So these are the flow tables. So like for folks watching, like it's not like you're going to understand all this today, but like I think this is just an introduction, and then we'll be able to go more into the flow tables later, right? Like this is just an initial. So we've got the node route controller, the peer node. So each one of these tables is, where is the table? There's a big list. Look at this pretty diagram here. Well, oh, this is not, why is this? I'm in high contrast mode or something. Here we go. Oh, this is beautiful. Look at this. So yeah, we could see how these tables here map over to what we saw in the other. I think the reason that the Antrea agent isn't showing any of these policies is because these policies don't apply to any of the pods on these agents, by the way. So I bet you anything, if I create a corresponding daemon set, right?
It could be. I didn't pay attention, but it can be the case. On the agent, you can only see the policy applied to the local ports.
Yeah, see? So now, once I deploy something, now you can see all these agents coming alive. And so this is a really useful metric because you can see if you have a large cluster and you want to know that your cluster is actually implementing the network policies correctly for the nodes are actually, the right nodes are implementing the right policies, you can go off and you can run this and you can see the places where the pods live are actually applying those policies. So it's actually a smart metric. So let's go back to that table one. What was that? What was that table? Flow tables. Antrea agent flow count, right? Here we go. Here, this one, right? Okay. So yeah, so if we go back here now, and when we put our tables on this other side, we can go in here and you can, I guess if you could sit here for like a couple of, you'd need a big cup of coffee to do this, but like you could sit here and you could start figuring this stuff out, right? Because like, for example, are these tables the same as these tables? Like, is this table, this 30?
The table ID should match the table you saw in the picture here.
Yeah, so like this is the contract table. This is how many rules are in there. And, you know, like, let's see, there's an endpoint DNAT. There's a service load balancer table. So like that's going to be 0 because we're not, I don't think we have a load. Oh, well, no, it's not 0. Oh, this is the internal service load balancer. This isn't the, okay, cool. Okay, great. But the service load balancer table, yeah, this is for, so is this for Antrea proxy over here? This isn't, in normal Antrea cluster, I wouldn't have this, right?
It's for Antrea proxy. But
yeah, it's for,
we enable Antrea proxy by default.
Oh, it's by default. Okay, so we're running Antrea proxy right now. Cool.
Yes.
Okay. All right, interesting. All right, great. So, and since we only have like a few minutes left, I'm going to jump into one last quick thing that I promised folks we'd look into, which is an upstream kube thing, which is we were going to look at this. There's a new bug that was filed on Coop Proxy. Speaking of why it's a great idea to run Antrea proxies, because look, Coop Proxy has a bug and it's not going to be fixed till the next release. But I bet you anything, it's going to take us more than 10 minutes to go through this. But anyway, so this is an interesting bug that was just filed around session affinity. So if you look here, I think there's an issue. I don't know if this issue is described somewhere or not, but there was a problem where in the code somewhere, session affinity isn't honored for endpoints that are not ready yet. So I think what Dan Winship's doing here is he's added something to check for non-ready endpoints and making sure that those endpoints that are not ready yet also have the session affinity in them. So for folks that don't know how the kube proxy code base is structured, you have this one function here, which is called proxier.go, this one file. And this file has like a 1,000-line method in it. It's called sync proxy rules, right? So if I go into here and I look at the sync proxy rules method, right? Sync proxy rules, right? If I go into this function, where is it? You can see it's called all the time, right? And so all the kube proxy logic sort of falls on this one function to synchronize everything. And ready endpoint case. And I think the gist of this PR is ultimately that like the calculation of the ready endpoints or something is happening like at the wrong time. Like it's happening, where is it? Let's go back to that PR. Yeah, changes around ready and did not get applied to the session affinity code. So so for folks that don't know how session affinity works, I guess what's the main use case for session affinity? Like if you got a web app and you have a connection to a server, right? Like you might have something like this. You have a pod, okay, and you have a client. You have like, here's Yash over here. And Yash makes a connection to this pod, right? But this pod is this pod is part of a deployment, right? It's part of a deployment, and that deployment maybe has 2 replicas, replica 1 and replica 2. And let's say there's a cookie or something. There's some transaction here where he wants to cache that data on the server so he can go back and forth and have a performant, interaction with that server back and forth. and not accidentally get load balanced to here, right? So this is the idea of session affinity, right? So the idea of session affinity is, that you're going back and forth to the same endpoint. You're not getting bounced back and forth to new endpoints. So yeah, I mean, in the worst case scenario, you might lose this pod, and then it would be great for you to start a connection to a new one. But as long as this pod is around, you want to keep going back and forth to it because it's cached your cookie data and whatever other data, right? So that's the whole idea. So right now, I guess in Coop Proxy, if an endpoint is not currently ready, right? Because an endpoint, if I do kubectl get endpoints, y-a, right. Okay, so
Sorry, just a quick question for folks who are still new to this. So is session affinity something that you define at service level, or is it at pod level, deployment level? Where do you say that you want to enable session affinity?
I think when you enable it, it's done. Let me see here. So I assume it's done at the service level, but I'm not sure. Let me check, because a service is the place where you have to define this, right? Like, let's see if we have a service that does that. Where is it? Let me see if I can find one. Yeah, I think I've got one over. Let me grab the services doc. So I think it's done at the service level, right? Because it's in the service API. So if I go to grep.app.
Yes, session affinity is an attribute on service spec.
Yeah, it's part of the spec, right? Yeah, here it is. Yep. Yeah. So it's in the spec itself, right? Where you say session affinity, right? And it's part of the data model for Kubernetes services is that, these are all attributes of the service, and one of them is session affinity. And so the way that this is interpreted is inside of the Coop Proxy itself. The Coop Proxy is watching all your services, and it's grabbing them, and it knows inside the code, it knows if a service that it's creating rules for has this attribute defined or not. And if it's got that attribute defined, then it has to make rules differently than it would otherwise. And so if an endpoint is, so in this case, if one of these endpoints is ready, here's all the logic in here that does this.
Yeah, and looks interesting.
Yeah. So tell us, is the Antrea proxy handle session affinity, Jiunjen? I'm curious now.
Yeah, we support that.
Cool. Okay, that's cool. So, well, there's another good reason to run Antrea proxy. So it'll be interesting. Jiunjen. Maybe we can one of these days run the tests. These weren't tests caught in the existing Kubernetes tests. So it'll be interesting to build better tests that actually catch this in the future. And for folks that are interested in doing that, me and Nameem and some other folks are working on this service load balancer validator that is going to make it super easy to understand what all the service tests are doing. And if folks want to contribute, this is a really cool place to contribute and really learn deeply about how Kubernetes services are working. And literally in 2 or 3 minutes, Nameem is going to be teaching some people how to do that internally here at VMware. But if other folks want to learn, feel free to reach out on Kubernetes Slack in the SIG network room to any of us. And
it's cool.
Yeah.
Probably we should include Antrea proxy test with this.
Yeah, we could totally. It would be great. Like we could use Antrea as the CI for this for sure. Yeah. And then you'd have all these beautiful test results, right? So like as an example of why these are useful, this is an example of when you have the what is it called? Local. What is it called? It's the service type where you only load balance to things that are on the same node that you hit. And so in that case, these endpoints will accessing these endpoints will fail, but accessing these will succeed. And this is a common thing that is really common in upstream issues that people report. They'll report a bug and they'll say Coop Proxy isn't working. And they'll give you like one pod not talking to one other pod. And so then you say, well, what about pods on this node? What about pods on that node? And you go back and forth on a GitHub issue for like, 24 days, and then the issue gets automatically closed by the Kubernetes bot because you weren't able to get the data out of them. So now we could just say, good, go run this thing and then show me the pictures, right? So I could see, and then you can immediately see that networking is unstable on these other nodes. And we use scheduling Affinity to make sure that these pods are separated, so that this table gives you a readout of like, this is node 1, this is node 2, this is node 3, right? So this will make it super easy to debug Kubernetes services and custom service proxies like Antrea proxy in the future. And we've got about 40 tests to write as we port over the existing Kubernetes end-to-end tests to use this table model. So plenty of room for folks to contribute. Cool. So we're at 5 o'clock, and I don't want to make everybody like spend all day hanging out with me. So here, Amin is here. Okay. So reach out to us in Upstream Kubernetes if you want to get involved with that. All right. Gonna jump. And anything else anybody wants to say before we jump? Otherwise, I'll just say thanks to Yash and thanks to Vivek and Junjan. And make sure to come back next week to learn about telcos and multi-cloud and all that stuff.
Yeah, all the notes are in the GitHub repo for the.
Cool. All right, you committed this hacked MD there? Great. Okay. Cool. So yeah, check out our GitHub repo and play along at home if y'all are interested. It's here, antrea-LIVE on that same K8s prototypes repo here, and you can go to this table and you can go here and you can grab all the notes from. Wait, they're not there, Yash. We got to update the notes. What are you doing?
I'm syncing it.
They're going to be here. Okay, they're going to be here. They're going to be right here. Yash is going to do it. Okay, cool. Thank you, everybody, for coming today. Thank you. Thanks, and we'll catch up next time. We'll catch up in next week at the same time.
Thanks, Jay.
Bye-bye.
Thank you.